So in this tutorial we learned how the OFB mode of a block cipher works, and we implemented it according to our own programming and according to the OFB mode available in the pycryptodome library. How do we convert a block cipher to a stream cipher? The short answer is output feedback mode. Now, what is this output feedback mode? We will understand it by the use of this diagram. So first of all, there is an initialization vector and we encrypt it using the given block cipher. Let us say that the size of the initialization vector is 64 bits. So after the encryption, this key stream 1 will also be of 64 bits. Now, this key stream 1 is XORed with the plain text 1, and the plain text is also divided into the same size of blocks. So these two blocks are XORed and we get the ciphertext 1. Now let us get back to what we did just now. We took the initialization vector, we encrypted it, and we got keystream 1. Now we encrypt the keystream 1 again and we get the keystream 2. Now we XOR this keystream 2 with the second plain text block, and this XOR results in ciphertext 2. The same process is repeated and we get ciphertext 1, ciphertext 2, ciphertext 3 for plaintext 1, plaintext 2 and plaintext 3. So this is a complete diagram of output feedback mode. Now we learn how to implement the OFB mode of AES. So we have already imported AES function and get random bytes function, and we have written a new function also which is XOR bytes. So it just computes XORs of two data of in form of bytes of same size. So now we implement the OFB mode of AES in two ways. Firstly, we implement with the given function in the pycryptodome library. So for that, we initialize the cipher as AES.new, and we need here the key and we need the mode. So we write AES mode and OFB. In this mode, as we saw, we need an IV also. So we write IV equal to IV. Till now we haven't defined the key and IV, so we will do so in this statement. Key equal to get random bytes 16 and IV equal to get random bytes 16. Okay, now we will encrypt our plain text. But what is plain text? So we create that randomly too. Plain text array equal to get random bytes 16 for in range, let's say we are using 4 blocks. Okay, now why I have created the array? This is because in the second term we will implement it using our own programming. So this is our plain text array and we will form the plain text from this array. Plain text equal to, we will use the byte string and we will use the join function to join all of these blocks. So plain text array. Okay, now this is the cipher and now we encrypt it. So we write ciphertext equal to cipher dot encrypt and plain text. Now we print the plain text. So the plain text is, and we print here the plain text. Then we print the ciphertext. The ciphertext is, and we write the ciphertext. So let's see if it is working or not. Okay, here we have got the output that the plain text is this and the ciphertext is this. So encryption is working fine. Now we will learn how we can implement it using our own programming. So as we created the plain text in the form of array, we will use this array to encrypt now. We have the key and we have the IV. So according to the diagram that we just saw, we first of all encrypt this IV. So for that we define cipher2 equal to AES dot new, and we write it here the key and AES mode ECB, that is electronic codebook mode, that is the most basic mode of the AES. Now we first of all initialize as key stream equal to IV, and now we do for I and range length of plain text array, like how many blocks of plain text we do have. Then we do the encryption of this IV. So key stream equal to cipher2 dot encrypt, and we write here the key stream. Why? This is because we will take the IV, we will encrypt it, and this will be our desired key stream to XOR. Now we write ciphertext. Okay, so we haven't defined the ciphertext array till now. So we defined it here, ciphertext array equal to as a blank array. Now we append it, append XOR bytes, and we append key stream and plain text array and its ith element. So the key stream will be XOR'd with the ith element of the plain text array. This is what we require. Now we print the ciphertext array. So we print that ciphertext according to our implementation is, we write print ciphertext array, and let us see if they both are coming same or not. Okay, so there is some array. The bytes object has no attribute of append. This is because we haven't used ciphertext array here. We just wrote ciphertext. So we write here ciphertext array. Now we run it again, and we see it has given us the output. So the plain text was this, the ciphertext is this, and according to our implementation, the ciphertext is this one. We see that the ciphertext array is exactly same as the ciphertext given by the OFB implementation in the pycryptodome library. So in this tutorial we learned how the OFB mode of a block cipher works, and we implemented it according to our own programming and according to the OFB mode available in the pycryptodome library.